In this video, we will study Boyle's law. In 1662, Robert Boyle studied the relationship between the volume and pressure of a gas at constant temperature. This was stated as Boyle's law. Now we will see the statement of Boyle's law. Boyle's law states that the volume of a fixed amount of gas at a given temperature is inversely proportional to the applied pressure. The volume of a fixed amount of gas at a given temperature is inversely proportional to the applied pressure. Mathematically, it can be written as V is inversely proportional to 1 upon P, where V is the volume and P is the pressure. Now we will write the mathematical form of Boyle's law, that is V is inversely proportional to 1 upon P, or we can write as V is equal to K upon P, or it can also be written as Vp is equal to K, where K is proportionality constant. The value of K is same for the same amount of a given gas. Therefore, Boyle's law can also be stated as, now we will see the second statement of Boyle's law. Boyle's law can also be stated as the product of pressure and volume of a fixed mass of a gas is constant at constant temperature. The product of pressure and volume of a fixed mass of a gas is constant at constant temperature. Mathematically, we can write as P1V1 is equal to K, where P1 is the initial pressure while V1 is the initial volume, that is P1V1 is equal to K. If P1V1 is equal to K, then P2V2 is equal to K, where P2 is the final pressure while V2 is the final volume. If P1V1 is equal to K, if P1V1 is equal to K, where P1 is the initial pressure while V1 is the initial volume. It means the product of initial pressure and initial volume is a constant quantity at given temperature. Then P2V2 is equal to K, where P2 is the final pressure and V2 is the final volume. It means the product of final pressure and final volume is also a constant quantity at constant temperature. As both equations have same constant, therefore their variables are also equal to each other. So we can write as the product of initial pressure and initial volume is equal to the product of final pressure and final volume, that is P1V1 is equal to P2V2. This equation establishes the relationship between pressure and volume of the gas. I hope Boyle's law is clear to you. Now we will study experimental verification of Boyle's law. The relationship between volume and pressure can be verified experimentally by the following series of experiments. That is, we will discuss the experimental verification of Boyle's law. In these experiments, let us take some mass of gas in a cylinder having a movable piston and observe the effect of increase of pressure on its volume. When the pressure of 2 atmosphere is applied, when the pressure of 2 atmosphere is applied, the volume of gas reads as 1 cubic decimeter. When pressure is increased to 4 atmosphere, then the volume of gas reduces to 0.5 cubic decimeter. Again, when the pressure is increases 3 times, that is 6 atmosphere, then the volume reduces to 0.33 cubic decimeter. When we calculate the product of volume and pressure for this experiment, then the product of all these experiments is constant, that is 2 atmosphere cubic decimeter. It proves the Boyle's law. Now we will do the calculation to see how the product of all these experiments is 2 atmosphere cubic decimeter. According to Boyle's law, product of initial pressure and initial volume is a constant quantity, that is P1 V1. We know what is the initial pressure in the experiment. The initial pressure is 2 atmosphere and the initial volume is 1 cubic decimeter. By multiplying, we get the answer, that is 2 atmosphere cubic decimeter. Similarly, P2 V2. We know if we increase the pressure from 2 atmosphere to 4 atmosphere, so value of P2 is 4 atmosphere and the value of V2 is 0.5 cubic decimeter. By multiplying, again we get the same answer, that is 2 atmosphere cubic decimeter. Similarly, P3 V3 is equal to P3 is 6 atmosphere and V3 is 0.33 cubic decimeter. By multiplying, we get 2 atmosphere cubic decimeter. The product of all these experiments is constant, that is 2 cubic decimeter atmosphere. So it proves the Boyle's law. I hope experimental verification of Boyle's law is clear to you. This is the graphical explanation of Boyle's law. We plotted a graph between pressure and volume by taking the volume on x-axis and pressure of a gas along y-axis. When the pressure of gas is plotted against volume, we get a curve. A curve is obtained. This curve is known as isotherm because it is constant temperature plot. This graph shows at constant temperature, the volume of gas decreases if we increase the pressure. I hope graphical explanation of Boyle's law is clear to you. Now we will do some important numericals based upon Boyle's law. The first numerical which is given is the pressure on 2.5 cubic decimeter of ethene changes from 1.05 to 2.10 atmosphere. The volume of ethene becomes 1.25 cubic decimeter. If the temperature remains constant, explain this change using Boyle's law. Now first of all, we will write the data for this numerical and then we will use the formula to solve this question. Here we will notice temperature remains constant. When the temperature is constant, then we use Boyle's law to solve the numerical. Now we will write the data for this question. Here we will see what is the initial pressure, that is 1.05. 1.05 is the initial pressure, that is P1, while 2.10 is the final pressure, that is P2. Similarly, 2.5 cubic decimeter is the initial volume, that is V1, while 1.25 is the final volume, that is V2. Now with the help of these values we will write the data for this question. The data is Now what is P1? P1 is equal to 1.05 atmosphere, while P2 is equal to 2.10 atmosphere. 2.10 atmosphere. Similarly, atmosphere. V1, that is initial volume, is 2.5 cubic decimeter, while final volume which is given V2, it is 1.25 cubic decimeter. Since temperature is constant, so we will apply Boyle's law here. According to Boyle's law, the product of initial pressure and volume is equal to the product of final pressure and volume. So we will write the formula which is used here, that is P1 V1 is equal to P2 V2. Now we will substitute their values. We know the initial pressure is 1.05 atmosphere, while the volume is 2.5 cubic decimeter, is equal to the final pressure 2.1 atmosphere multiplied by the final volume which is given is 1.25 cubic decimeter. Now we will calculate here. If we multiply 1.05 with 2.5, we will get the answer, that is 2.625 atmosphere cubic decimeter. Atmosphere cubic decimeter is equal to, by multiplying 2.1 into 1.25, we will get 2.625 atmosphere cubic decimeter. This calculated result agrees the pressure volume relationship according to the Boyle's law. We know according to Boyle's law, the product of initial pressure and volume is equal to the product of final pressure and volume. I hope this numerical is clear to you. Now we will see the next numerical which is given to us. Now we will see the next numerical which is given. A gas with a volume of 350 cubic centimeter has a pressure of 650 millimeter of mercury. If its pressure is reduced to 325 millimeter of mercury, calculate what will be its new volume. The question is, a gas with a volume of 350 cubic centimeter has a pressure of 650 millimeter of mercury. If its pressure is reduced to 325 millimeter of mercury, we are asked to calculate what will be its new volume. Now we will write the data to solve this question. First of all, we will write the data for this question, and then we'll see what formula is used to solve this question. The data is, now initial volume which is given V1, it is 350 cubic centimeter. So V1 is equal to 350 cubic centimeter. And initial pressure which is given, that is P1. P1 is equal to 650 millimeter of mercury. 650 millimeter of mercury. P2, that is final pressure which is given, it is 325 millimeter of mercury. 325 millimeter of mercury. And we are asked to calculate new volume, that is V2, the final volume. So here we will use Boyle's law to solve this numerical, that is P1 V1 is equal to P2 V2. We'll use this formula according to Boyle's law. P1 V1 is equal to P2 V2, or we are asked to calculate V2, So we will rearrange this formula. It will be P1 V1 upon P2. Now we will substitute the values, given values in this formula. We know initial pressure which is given P1 650 millimeter of mercury, multiplied by initial volume which is given is 350 cubic centimeter, divided by final pressure which is given 325 millimeter of mercury. Now by calculating we get the answer. V2 is 700 cubic centimeter. So in this way we calculate the final volume. The volume of gas is doubled by reducing its pressure to half. What is the conclusion? If we reduce the pressure up to half, the volume of gas will be double. I hope this numerical is clear to you. Now see the next numerical which is given. 785 cubic centimeter of a gas was enclosed in a container under a pressure of 600 millimeter of mercury. If volume is reduced to 350 cubic centimeter, what will be the pressure? Once again we will see the statement of the question. 785 cubic centimeter of a gas was enclosed in a container under a pressure of 600 millimeter of mercury. If volume is reduced to 350 cubic centimeter, what will be the pressure? Now to solve this numerical, we will write the data. First of all, we will write the data of this question and then we will see what formula is used, which law is applicable. So we write the data for this question to solve the numerical. Now initial volume which is given, that is V1, which is given is 785 cubic centimeter. 785 cubic centimeter. And initial pressure P1 which is given, it is 600 millimeter of mercury. 600 millimeter of mercury. Similarly, the final volume which is given, that is V2, which is given is 350 cubic centimeter. 350 cubic centimeter. And we are asked to calculate the final pressure, that is P2. We are asked to calculate P2. So here we will use Boyle's law, that is the product of initial pressure and volume is equal to the product of final pressure and volume, that is P1 V1 is equal to P2 V2. So by using Boyle's law we write the formula P1 V1 is equal to P2 V2. Since we are asked to calculate final pressure, that is P2, so we rearrange this formula. P2 is equal to P1 V1 over V2. Now substitute the values in this formula. P2 is equal to 785 multiplied by initial volume which is given 600 divided by the final volume which is given 350. So the final pressure, by calculating we get the answer. The final pressure is 1.77 atmosphere. The answer which is obtained by calculating is 1.77 atmosphere. This answer shows that the pressure is increased by decreasing volume. It means when the volume is decreased, definitely pressure is increased. I hope this numerical is clear to you.